welcome to the section of this course. Today I will be speaking about the first principle of derivative. Sometimes we call this AB initio, or sometimes we call first principle. Okay, this is the concept of derivative. Okay, derivative means it's a slope. Okay, now if I have a function fx is this way. Okay, now in this x-axis I have a point x over here. Okay, now where x plus h is some increment where h is greater than 0. Okay, some increment in x. So since x is there, so I'm keeping x plus h point over here. Okay, some increment in x. Okay, similarly, if fx, according to the x, we have fx over here in this y-axis. Okay, now here this is what x comma fx. Okay, similarly, if we have x plus h, accordingly we have f of x plus h. Okay, now here this point is x comma f of x, and here this is x plus h comma f of x plus h. Okay, now slope is for difference is this. Okay, you can say change of y upon change of x is equals to, okay, change of x is what? Change of x equals to, what is change of x plus h minus x is what? We'll get x plus h minus x is, here you can say x plus h minus x. I will get change of x. Okay, but over here change of y is what? F of x plus h. Here we have x plus f of, here we have f of x, here we have f of x plus h. Okay, now here we will get f of x plus h minus fx is change of y. Okay, here I can say f of x plus h minus f of x. Okay, now this is same as f of x plus h minus f of x. X gets cancelled. I am having here h. Okay, now this is same as we call f dash x, or you can say this is what? dy by dx is equals to limit of where h tends to 0. Okay, when h tends to 0, this approaches to 0. Okay, so therefore here h tends to 0. This is called what? First principle of derivative. Okay, this is a man. It means f of x plus h minus fx means change of y upon change of x when limit h tends to 0, very near to 0, then that is dy by dx. Okay, let's take some example. Say example 1, we can say question 1, find it. The question may be like this: find x square by first principle of derivative, or you can say some textbook, as I told you, it's AB initio. Okay, now okay, since this type of questions, what we have to do is let fx equals to x square. Okay, let f of x equals to x square. Now look at here. Okay, now if you have f of x, then you need to find f of x plus h. Okay, since f of x is this, therefore f of x plus h is what? Now instead of x, now otherwise you can say instead of x, what, you have to put x plus h. Okay, so therefore instead of x, I am putting x plus h the. Also, what I'm doing is, if fx equals to x square, then f of x plus h will be x plus h the whole square. Okay, if it is f of x equals to x cube, then it will be x plus h the whole cube. Okay, therefore limit of, you can say it is f dash x equals to limit of f of x plus h minus f of x upon h where h tends to 0. Okay, this is definition. Okay, definition from first principle. By substituting over here these values, what we have is limit of h tends to 0. F of x plus h is what? X plus h the whole square minus x square upon h. Okay, what I am doing is just I am substituting this formula. Okay, what is f of x plus h? F of x plus h is what? X plus h the whole square, and f of x is what? X square. Okay, here x square is equals to limit of h tends to 0. Expanding this is a plus b the whole square formula. Here I have x square plus twice x h plus h square minus x square upon h. Okay, now x square gets cancelled. Now I can take h common here. Okay, from the numerator. Okay, here h tends to 0. If I am taking h common here, what will have? I have twice x plus h, because h into h is h square upon h, and this h and h gets cancelled. Then when limit h tends to 0 means you have to substitute h equals to 0 over here. Okay, when I substitute h equals to 0, it's become what? We are getting only twice x. Okay, therefore by first principle the dy dx of, or you can say x differentiation of x square become a twice x. Okay, now these are three sums. Okay, we have to find by first principle of derivative. Okay, this is a very easy one, so we'll start it from easy to somehow more difficult. This is all algebraic. Okay, we can, after this we'll do exponential, after this we'll do logarithm, after this we'll do trigonometric functions. Okay, many functions. After this we can do like many functions, inverse trigonometric functions, algebraic, exponential. So mix of the functions we will do. Okay, firstly we are considering only algebraic functions. Okay, now let's consider f of x. So by first principle what we have is, just remember, limit of f of x plus h minus f of x upon h, where h tends to 0. Okay, remember this is only formula. Okay, for the first principle. Now you have to consider the given function is function of x. Okay, since it is x cube, so let f of x equals to x cube. Okay, now since fx is there, so we need to find f of x plus h. Okay, in order to use this formula we need to find x plus h. Therefore f of x plus h is what? Instead of x, you put x plus h. Okay, you write x plus h the whole cube. Here you can expand a plus b the whole cube is what? A cube plus thrice a square b plus thrice a b square plus b cube. This is by a plus b the whole cube. Okay, now we have fx, we have f of x plus h. Okay, now you can substitute over here. Why? Because by first principle. Okay, by substituting over here you'll get f dash x is equals to limit of h tends to 0 f of x plus h. Okay, here this I have f of x plus h. Okay, f of x plus h is what? X cube plus 3x square h plus 3x h square plus h cube. Okay, minus what? Fx. What is my fx? Fx is what? X cube upon h. Okay, I'm not doing anything, just first I am finding f of, just I am assuming f of x, the given function I am assuming f of x. After that I am finding f of x plus h. Why? Because this I need f of x plus h. Okay, now substituting over here, because this is the first principle concept, limit of h tends to 0 here. Okay, now x cube gets cancelled, and from here also I can take h common. Okay, limit of h tends to 0. Here I can, if I take h common, then what will have? 3x square plus 3x h plus h square upon h. This h gets cancelled. When h tends to 0, this term will get 0, this term will get 0. 0 plus 0, what I will have? This is free from h. Okay, so since it is free from h, I will be getting 3x square. Okay, this is required answer. Okay, now next is what? 4x minus 3. Okay, we have to consider this fx. Okay, now f of x equals to what? 4 of x minus 3. Okay, now since f of x is this, okay, we need to find what? F of x plus h. Okay, now what you have to do, instead of x you have to write x plus h, or those places which are x, what you have to do is you have to write x plus h instead of x. Okay, here what we'll have? 4 x plus h minus 3. Okay, if you can explain even 4 of x plus 4h minus 3 by this formula, limit of f dash x equals to limit of h tends to 0, f of x plus h is this. Okay, here we have 4x plus 4h minus 3 minus, we have, since minus is there, keep bracket 4x minus 3 upon h. Now if I open the bracket, okay, this 4x and this is minus 4x, this is plus 4x. Okay, this will get cancelled, and here what we'll have is minus 3. Okay, here minus plus 3, minus 3 plus 3 will get cancelled, and what I'll have is limit of h tends to 0, 4h upon h, because minus 3 and minus plus 3 get cancelled, 4x and minus 4x gets cancelled. Okay, here h gets cancelled. What I have is, we have only 4, limit of h tends to 0, 4. Okay, since it is constant, h tends to 0 doesn't have any effect, therefore we have 4. 4 is the correct answer. Okay, now 3, it is given x square plus 4x. Okay, now f of x is what? X square plus 4x. Look at very carefully over here. Now you have variable x, here also there are two terms of x. Okay, here x square plus 4x. Okay, here x also there, this x also there. Okay, now in order to find f of x plus h, instead of x, what we have to do? Instead of x, you have to write x plus h. Okay, here instead of x, I have to write x plus h the whole square plus 4x plus h. Why? Because instead of x, since fx is this, instead of x, what I'm doing, I'm writing x plus h. Okay, so those places who are in those places who have x, you have to write x plus h. Okay, here x plus h, x plus h. Now expand one step. Here a plus b the whole square, we have a square plus twice xh plus h square plus 4x plus 4h. Okay, now applying this formula, f dash x equals to limit of h tends to 0, f of x plus h is this. Okay, here x square plus twice xh plus h square plus 4x plus 4h. This is my f of x plus h. Okay, minus, what is fx? This is my fx. Okay, fx is x square minus 4x. Okay, so I am sending minus inside. Okay, if I am sending minus here, I will get x square minus 4x, because plus minus minus. Okay, here x square gets cancelled, 4x gets cancelled upon h. Here limit of h tends to 0. Here I am taking h common. Okay, if I take h common, what we have is twice x. We have twice x plus h plus, here we have what? 4. Okay, here 4 upon h. Now this h and this h gets cancelled. When h tends to 0, this become a 0. What we have is twice x plus 4. Okay, here we have twice x plus 4. Okay, this is the correct answer. Okay.